For this Sunday we will finish what we will stop taking new topics. Okay, we will stop at Sunday. We will have the last session. Then we'll work on projects where I will interact with you individually. So every day I will try to interact with 4 or 5 members, and I will explain you the project and I will check what you are doing. So in that way we'll go, because next week will be our last week. Sunday, whatever topic we will finish till then, I will then give you projects where you will work, and I will be guiding you personally for the last week. Okay, so that's how we will wind up the course. Okay. After that, if you are interested, you guys can contact me. If you are interested to learn further about machine learning or analog design, we can plan a separate course later. Okay, but for internship purpose, we will wind up this course next week. Okay, so this week, Sunday will be your last theory topic. Then it will be projects where I will talk to you individually. Okay, so today we will take up one topic of simple, and already we know the most of the topics here, but yeah, decision tree classification. Okay, what is decision tree? We have already seen decision tree classification. So basically there is a regression tree, classification tree. We have already seen regression tree. It will exactly work similar to that of a regression tree, the way it works. Classification, actually this decision tree algorithm is meant for classification. Okay, here we will divide the data into different groups. Okay, see, there are only two groups present. Okay, red and green, but the green is present in two different locations. That's how it will help you to classify things which are non-linear. Okay, in case of linear thing, which it was very easy. Okay, but here this green is also yes, and this green is also yes. Reds are present here and there. So classification, this form of classification will help you to organize your evaluate your data more easily. Okay, so here what it will do, first it will check one of the condition, x2 less than 60. So it will do first line. Okay, this is the first. Okay, it will do first line. Okay, here first big split greater than 60. Next what it will do, split 2, 50, the value should be less than 50. Okay, so this one less than 50, one more split. Okay, and less than 70, one more split. So split 1, split 2, split 2, split 3, split 2, 50, split 3, 70. Okay, so these two splits, finally one more split. Okay, and based on that it will decide this data, and it will take care of the classification part. Okay, now random forest, exactly same thing. The way in regression it was there, same thing it will do here. It will split data. It will not split the complete data. It will take, say, out of 1000 data, it will take say 100 data. Then it will do all the splitting, whatever it was doing here, it will do that same thing, but for few data. Then it will go back, it will next take another set of few data randomly, and it will not take one corner data randomly. It will pick different data, and it will create this to those random data. So you might get 10 different data and 10 different classification. Okay, then what it will do, one new point will come. That new point, it will put that new point into 10 different classification, and from all that you will get one average result, whether it belongs to true or false. Based on that it will give a final result, that is random forest. Decision tree will do it for full data, random forest will do it for small data, but multiple times, so that it will cover almost all the data. Okay, so now let us see the code for that. First we'll see decision tree. Okay, nothing is changing, nothing is changed here. This is same, this is also same. This is also same. Here we are going to use decision tree classifier. Criteria is entropy. So random forest state is 0. Okay. This will be your only change in this complete code. Now everything else is same. Okay. I will comment this out. Calculate the accuracy here. Okay, so the accuracy is 0.9%. Okay, 0.91%. So that is the accuracy of decision tree classification. Okay, I will share this so you guys can see. Your task is for all the codes which I am sharing. What you must do is you must focus your all energy here. Okay, these one line. Okay, this one line you have to focus all your energy, and you should try to see the different parameters which are there inside this classifier and try to improve the efficiency from 0.91 to say 94, 93, 92. Are you able to improve that by changing any of these parameters? I have just mentioned two. There are 10 different parameters which are there, which are kept by default as whatever value is there, default we have kept. If you are able to improve it, not by trial and error, by understanding the concept, then it will really help your machine learning algorithm. Okay. Maybe I will Sunday I will show you one case where I have improved so that you guys can apply it in all other algorithms. Okay. Next one. No, you guys can try this first. Try to visualize it for 4 minutes. Take your time, see this data, and check. Then we will maybe 2 minutes is enough. Then we will go to the next topic of random forest. Okay. I will share the random forest code. Okay. So let us go to the next topic. So decision tree, similar to decision tree, now there is random forest. Okay. So here number of estimators we have kept 10. Okay. So once I share the code, you guys can try the number of estimators to be different values. Okay. 4, 5, 6. You guys try that. So this one is giving us still 0.91. Okay, let us reduce or increase the number of estimators to 20 and check if the accuracy will improve. So slightly it got improved. Okay, from 0.91 it improved to 0.92 by increasing number of estimators. Can I keep increasing this and improve my result? Let us see. So there is no improvement. If I make this as 100, let us see. If I make this as 100, there might be a chance it will come down also. Okay. So it has come down. Okay. So this algorithm maximum it can give 0.92. You have to check other parameters also and check what are the other parameters in which in that algorithm and how it is impacting our result. Okay. So I will share this code. Try this for 2-3 minutes. Then we will go to a new topic called clustering today. Yeah, 1 more minute you guys can try. Okay. So now the next topic is classification, clustering. Okay, what is clustering? To see that, before going to clustering, we will see the data set. Okay, see clustering. Let me, yeah, clustering is not having any kind of true or false, yes or no, or head or tail. That kind of thing it is not having. Okay, it is just having some generic information. Okay, for example, in your, if you take your classroom, if there are say 40 students, if I take 10 different attributes, okay, students who are punctual in class, students who are doing assignments, students who are silent people who will not talk much, people who are not take, people who are energetic, people who are lazy. If I take some random information about all the 40 students, then what I can do at the end is I can group it and make it into say 10 clusters or 5 clusters. That means at the end you guys can be divided into 5 groups. Okay, so you guys have similar behavior, something like that. Okay, these 5 clusters means at the end of collecting all the information I can tell you guys belong to cluster 1, you guys belong to cluster 2, something like that. Then what to do with that cluster? That is our application where we can do. So some people who are very much good in extracurricular activities, then we will involve them into certain activities. Some people are very good in technical stuff, we will involve them in our projects. Some people, so based on different things we can apply that and we can conclude, so we can do some application on that. Okay, now what is this data here? This data is customers. There are like so many customers. Okay, these are customers, 200 customers basically. Okay, and they have some information, their age, their gender, their annual income, so 15K dollars. Okay, and spending score. So these guys will spend some money. Okay, so they, out of 1 to 100, people who spend the most are being given highest value. Okay, that's it. Okay, now how we can group this? Okay, there is nothing here. Okay, no output as such. Okay, just a generic information. Now we can do something, certain things with this. Okay, we can group this. We will not see the application part. Okay, we will just group these people and we'll check how this can be used, how, what is the number of groups we can get. Okay, so for that I am closing this data. Let it be present. Now how to group this? There are two different ways in which this can be grouped. Okay, one way is called as K means intuition understanding K means. Okay, what is K means? Cluster. First of all, let us see the definition. Cluster is similar to classification, but the basic is different. In clustering, you don't know what you are looking for. Okay, and you are trying to identify some segments or clusters in your data. When you use clustering algorithm on your data set, unexpected things can suddenly pop up like clusters, structures, cluster, and groupings you would never thought of otherwise. Okay, so this can be used in different applications. Here now let us see what do you mean by K means intuition. Understanding K means. Okay, how this works. We will not go into the algorithm here. We will directly see within live data. Okay, imagine this is your data. Okay, this is your data. Now let us blindly think that there are two clusters possible. Okay, so what I will do, I will randomly put 2 points, a random point. Okay, I don't know. I have. Okay, wait. See, these 2 points are not planned and placed. Okay, this point could have been present here, or this point could have been present here. So this algorithm will randomly put 2 points. Okay, randomly it will put 2 points, and then what it will do is this guy will create a centroid, and whichever point, see, it will check, for example, so this point will check what is the distance between this and this, which is farther. So this is nearer, this is nearer, so this will make this as group 1. Now this point here, which will check between distance between this and this, okay, this and this, which is near, so this will be group 2. Like that, all the points here will fall into group 1 and group 2. Okay, done. So randomly it has done two groups. Okay, this square block is not placed in a planned way. Okay, so next step, now see, this is your new group. Okay, this is your one group, this is your second group, red one. Okay, now what this algorithm will do is, this was the centroid it imagined initially, but after seeing all these points, it will decide that the actual centroid should be this one, because based on this, all your points are somewhat, centroid should be that point where maximum number of points are present. Okay, or it is equidistant from all the points, so it has shifted the point here, and this guy also shifted the point here. Okay, it will find the centroid for this particular red clusters. Okay, then finally your model is ready, and then you can come up with this solution. You got two clusters. Okay, but this is what, this all this started with the imagination that we have two clusters. What if you had thought there are three clusters? So we started our approach with k is equal to 2. If was equal to 3, then you would have ended up with three clusters. Now if k was 4, you would have ended up with four different circles. Now how to choose the right number of clusters? Okay, choosing the right number of clusters, whether you want two clusters, 3, 4, 5, 6, 7, 8, 9, 10, how to decide that? Okay, for that there is some idea. Okay, that is choosing the right number of clusters. So what we do is, we will start imagining that we'll take one cluster first. Initially we'll take one cluster. There is a formula called as, this is simple distance formula. Okay, what we do, I will explain this. See, so imagine we started with k is equal to 3. Okay, so our algorithm gave three clusters, 1, 2, and 3. Then this formula here, choosing the right number of clusters formula, what it will do is, it will take the square distance of this, and it will take the distance between the individual points from the centroid and square it and add it. Okay, this minus this distance square, 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 and this complete sum what you get, that will be added with this distance square, 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 that you will generate one sum, this will generate one sum, this will generate one sum. You will add all these three and you will get one number. What is that number you will get is WCSS. Okay, then what you will do, from three clusters you will jump to two clusters, then your algorithm will give two circles. Then again here we also calculate that same distance sum, centroid distance square sum, centroid, for all these things. Then again you will get what one value you will get, WCSS2. Previous it was WCSS3 because three clusters. Now it will be 2. Finally it will take 1 and it will see all this distance square. So when you do all these things, say you can do that for k up to 10. Okay, for 10, 9, 8, you will get WCSS value. The WCSS value should be less. The lesser the WCSS value, it will predict the grouping correctly. That is the algorithm. Okay, Now what it will do is, this is called elbow method. Okay, this is the WCSS value. See, this was with one cluster. If you have just one cluster, and if you try to find the centroid and do all the computation, you will get a very big WCSS value. Then slightly lower, then slightly lower, then it will not have much impact. Okay, then if you keep increasing the clusters, it will not have much impact. But what will be the problem if you keep increasing the clusters? Then you will not be having right number of groups. For example, if I take your class where there are 40 students and I group it into 40 or 20, that means in every group there will be two members. That will not have a bigger impact. Instead, if I group it into say 8, then I will have only 5 groups. Very nice to handle, and you guys will also enjoy that there are many people in one group. So that kind of feeling you will get. Okay, I'll be back in 1 second. Huh. Hello. Yes. Yes. So let us continue. Yeah. So that elbow method will tell us how many clusters we must do. Okay. So that elbow method will decide how many clusters we must do, and then you will get the right number of clusters. So let us see this on our algorithm and see the result. This is called as K means intuition. Okay. So let us see the program. Okay, so here now the code will change slightly. Okay, so I am taking 3 and 4 values. Okay, so from the mall customer, so this is our data set 0, 1, 2, 3, and 4. I am taking only these two right now, and I am trying to create a group. Okay, so that I can show the plots. Okay, show the plots how it will look. Or else you have to just see the groups and you have to decide. Okay, how it will work. So let me show you 3 and 4, then I'll show you the values. So this will give what will be the value of x. It will have all rows and columns 3 and 4. Okay, next, to do sklearn clusters we use k-means, and here we will do that clustering part. Okay, so k-means n clusters, one by one it will take, and it will take random state. You can keep any value, and then here at the end of this you will get that elbow method. Okay, let me show you the output. So this is our elbow output. Okay, this is telling us that if you keep clusters as 5 or somewhere around 6, you will get a right number of groups. If you keep increasing it further, it will not have much impact. Okay, you will only destroy the data. Okay, so maybe 4, 5, 6, somewhere between this, maybe 5 is the right value. Okay, now finally, if you want to see this visually, what we can do is, I am now I have got that I have to keep clusters as is equal to 5. Okay, I have to use clusters is equal to 5. That's why I am making n cluster is equal to 5, and I am predicting the I am giving this x. What is my x? This is my data. Okay, that I am passing here, and I will get yk means. Okay, then I will explain you this graph also what it will do. First, let us see the output. Okay, I will close this. Yeah. So this is your final clusters. Okay. So this is cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. So now that is the reason here in the program I had to use only 2. Okay. So 3 and 4. Okay. So 3 and 4, why? This is your 4 and this is your 3. Okay. Based on that, if you want to visualize this only, then we have to use 2. But if you don't want to do that, you just want to see it the number of clusters which are there, then you can keep all the variables and you can then define how many clusters you want to make. Okay, so if you want to do that, what you should do, you should just comment this visualization part. Okay, comment out region, then instead of 3 4 I will make 0 comma 1 comma 2 comma 3 4, and then if I run this, oh, where there? Okay, that mail and all is string is there, right? The string, I think we cannot keep it. Okay, so this one will remove 0, 1 will remove 2, and 2, 3, 4 will take. Okay, or else we have to do that one not encoder, and then we can do that also. Okay, very good. Okay, so now with that data also, it is giving me that 4 clusters or 5 clusters will be sufficient. Okay, but now we will not be able to see a plot as such. Okay, so this is the plot which will not make much sense because the plot is again now, see, although the plot is taking only x versus y, so you will not get the right value what we are seeing here. Okay, the plot will not make much sense here. Let me show you some other thing here. Instead of this, we will see yk means here. See, yk means is giving us some very important information. Okay, what is this information? See, we got to know that there are 5 clusters. Okay, and this is your data, right? It is telling me that first row belongs to cluster 1, cluster 1, cluster 4. So if I can put this in horizontal form, a vertical form, then I can just paste it here. Then it will tell me that this particular customer belongs to cluster 0, this will belong to cluster 1, this belongs to cluster 4, this also belongs to cluster 4, like that we can put. So that means then you will get groups. So these two are same group, these two are same group, like that we can do. So this is how this information can be used. So there will be 200 values here. Okay, there will be 200 values here. Okay, before proceeding further, I will share this code. You guys can run this and let me know. Okay, I have shared the code. There is one more algorithm which we will do. Okay, you guys can try and see how that number of methods will be. So this is your task. Okay, you have to figure out how this plot will work. Okay, I will be sharing this. Try to use this in this same code. I will share the full code. You have to figure out how this works. Okay, it's very simple. There is an important clue is what does this do. Okay, yk means 0 0. How this will use. Okay, how this will be used, you have to check. Okay, and then you have to, it will help you to get that data and it will help you to plot it. Okay, so try this. If you don't understand, let me know, I will help you. Okay, try for another 2 minutes, then we'll go to in clustering only. There is one more algorithm, we'll see that and we will stop for today. So try this for another 2 minutes. So your homework is understanding this, how, why this is used and how this will work. Okay, If you don't understand, let me know. Next time I will explain you this. See, this, since I made cluster is equal to 5, I have put 5 clusters here. Okay, scatter, 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 5. So how many are there? 6 are there. So no, total is 5, right? So this will be the final one. So finally this will also matter. Okay, so there are 4, 0 to 4. So 5 clusters are there here. Okay, so if you want to increase the number of clusters, then you have to change this algorithm, and it will you have to work in different way. Okay, so that is also there. So visualization you can only do on two variables, but groupism you can do on 18, 20 different number of variables. Okay, it will finally it will give how many groups are there. Okay, you can put that value here and you can create groups. So like this you can put. Okay, yes, let us continue now. Okay, here similar to k means there is one more algorithm called as hierarchical intuition understanding. Okay, so this is called hierarchical clustering. Okay, this is very simple method, and let us see with an example directly. Okay, there are mainly two methods of doing clustering. One is this and another one is this, k means and hierarchical clustering. Now let us go into hierarchical clustering and try to see the algorithm. So again, imagine we have 6 points. Okay, 6 data points are there. It will start by the assumption that each point is a cluster. Each individual point is one cluster. There are 40 students in your class. Each one are unique. Okay, it will start from that belief. Okay, so we will think everyone is unique. Okay, 40. Then what it will do? Then whoever are closer to each other. Okay, that take the two closest data points and make them as one cluster. Okay, so these two data points are very close by. Okay, these are the closest. Okay, for example, think that 40 students are unique, but I saw that 38 student and 37 student have almost everything resembling. Okay, compared to others. So I will make this as from 6 clusters. Now we have reduced to 5 clusters. Okay, now this, because we have made this as one group, total 6 clusters have been reduced to 5. Next, it will take the next two closest values. Okay, so now from 5 clusters we have reduced to 4. At the end we will have one cluster. So it will believe, it will start from 0, all 6 clusters, then it will go up to one cluster and it will finish that. Okay, then one important thing it will do is, when it is dividing and making a cluster, it will find the distance between that. Okay, what is the distance? See, first we made, see, these are now individual clusters. So this P1 is this, P2, oh wait, P2 is this, P3 is this, P4 is this, P P5. Okay, this is P5. Okay, this is P1. So this is P1, this is P5, this is P6. These are individual clusters. So 6 clusters. Okay. Then what we made? We made P2 and P3 one. So This is that one. And what is this distance? This is the distance between these 2 points. Okay. Okay, there are different ways in which the distance can be calculated, but this is how distance between these 2 points are calculated. Next, now what will be the next step? Next step, it will create and find the distance between these 2 points. So, which is by observation we can tell that this is nearer, this is far. So, the height is more here. Okay, so it will be a absolute value. Okay, it is not some assumption blindly visually we are not doing it. There is mathematics behind. It will find the distance here, this will find the distance here, and it will do this. Next step is it will create one more group here because these three are close by. So P1 is added with P2 and P3 with that distance formula. Okay, we got this, we got this. Next, this one is all now added here. Finally, we got this. Then finally we will get this. Okay, this is how we got our clusters. Now by looking into this we can say actually how many clusters we have to group our data into. Okay, how to do that? See, from here we must take the longest vertical line we must take, and we must divide that. So it will tell us that there should be two clusters. See, there is one line here, one line here. So two clusters. Let me show you one more example so that it will be that concept is clear. So if by doing this, it is saying that this particular data which we have must be divided into two clusters, then it will give a better answer. It is also, you can also define this using elbow method also. Okay, that classification of groups you can do based on elbow method, where elbow method we were seeing that elbow shape and we were deciding how many clusters. Here based on the longest vertical line we must decide. Okay, let me take one more example. So if you do 4, you can see it has grouped it in a wrong way. Okay, this makes much more sense than this data. Okay, see, you have to take the largest line which is not being, so this is the largest line. Okay, let me show you one more data here. Which is the longest line? Wait, here this is the longest line, but in between that there is a horizontal line which will cut this off. So this is not the longest line. So we have either this one or this one. Okay, I'll erase this. So we have only two longest lines. Okay, either it is this one red or this one red. Okay, and this one, these are the lines which are not being cut. So in this case there are three clusters, or this one you can take, then two clusters. Okay, it can be grouped either in three, but if you carefully see, this line is smaller than this line. Okay, so that's why we have to go with three clusters here. So but this is not the longest line. Why? There is a break here. Okay, but this one line there is no break, this line there is no break in between. So three clusters. Okay, now you can take the data set and we will see, and we'll stop for today. Wait, here I put that one, I'll remove that. Okay, so now this is the plot we will get. Okay, now if I want to decide how many clusters are required, then what I must do? I must see the longest line. Okay, there are how many lines here? Okay, so this is one line. Without doubt, this looks to be the longest. Okay, then so here this is not the longest. Okay, next longest is not this one because it will cut it here. Okay, it will break it here. So you have this longest line. So it is basically this is the longest line. Next, what is the next longest? Wait. This will break this. This will break this. So this is also breaking this. So basically, it will be two clusters which you have to take here. Okay. Now, if I reduce this data from 0, 1 to 2, and I'll just make 3 and 4. Let us see how it will look. Also, not K means, right? Hierarchical clustering. Let us see how the value will look. Yeah. So now it is more evident that which is the longest here. This is the longest. Okay. But it is breaking this one. Okay. This is not the longest. Now let me show you which is the longest and why not. So see, although it looks like this is the longest, but this line is breaking this line. Okay. So this is not the longest one. So this is not the longest. The red one, which I will draw, is not the longest. So next longest is this one. Okay. No one is breaking this line in between horizontally. So if I pass a line here, it will divide it into 1, 2, 3, 4, 5. So 5 clusters will make more sense here. Okay. If you consider 3 and 4 lines. Okay. 3 and 4. With this data, it is giving me that I should make the data into 5 groups. Then I will get the nice algorithm. Okay. Then if I use that and I do this visualization, I'm assuming now that cluster is 5 and I'm running this. Okay, I'll close this. Yeah, so this is how the plot will look. Okay, these are your 5 clusters. Okay, I will share this code. You guys can go through this and make sure you read all the algorithms and whatever is done. Sunday we will have another set of one more type of machine learning algorithm we'll learn, and we will then do some project work for 1 week. Okay, I will share the data set and we'll do the project work. So I will share this code. Hopefully you are working on that analog design project. Okay, we will meet on Sunday next. Okay, happy Ganesh Chaturthi to all of you. Hello, I'll stop now.